visit to the meeting too, so. There we go. All right, so, oh, sorry. Well, I'm special. I wanted to know everybody. I wanted to announce it's my first. Thank you very much for the invitation. I truly appreciate it. A little bit about me. I'm a super geek by trade. My dad was a software developer. I was writing computer software when I was 12, and I just can't seem to get away from it. So if I get really excited and overly geeky and I start getting really loud, I will not take offense if anybody says, chill out. Okay, so don't worry about it. In fact, I'll probably end up putting this mic down about 4 slides in because I'm going to get pretty excited. I live up in Ramona. I moved to San Diego from Palm Springs about 5 years ago. Spent 15 years up in Palm Springs. When I moved down here, all of my radios stayed in a box until about 6 months ago. And all of a sudden, a neighbor of mine came over and he goes, "Your wife says you're a radio operator." I go, "I am." And he goes, "Me too." And all of a sudden, it was just, I'm all over it again. So I've been setting everything back up, getting everything going again. So it's nice to get to meet the local communities. I've been kind of making the circuit and visiting the different clubs, and this is a big club, and I really appreciate the invitation coming out. Anyway, my name is Eric Goforth, N6GOF. If somebody can help me figure out how to change my darn address with the FCC, I'd really appreciate it because I've been trying forever. Boy, man, I know everybody keeps looking me up. They go, "Ooh, this says you're in La Quinta." I'm not. Anyway, tonight I'm going to be talking about APRS, and APRS is not new. And because it's not new, there's going to be a lot of people in this room that are going to go, been there, done that. However, it's kind of fallen out of favor in the last few years in lieu of other kind of fun toys, or kind of a misconception about what really APRS it was built and designed for and what it can really do for you from a capability standpoint. So I think it's kind of good that we kind of revisit it and kind of come back through and talk a little bit about what APRS is. APRS is the automatic packet reporting system, and a lot of people who have looked into APRS, the first thing they'll see is that there's a lot of maps and icons on maps, and they kind of confuse it with automatic position reporting system. So you'll hear that sometimes, APRS as a position as well. It's really a lot more than just positions. As I thought about doing this presentation, I thought there's going to be people that have been there since the very beginning, 1979, and all the way up until the brand new FT400 came out, and they got that little supplemental APRS manual off of Yaesu's website, scratching their head wondering what it did. So I'm going to try to go all the way through it, skip a stone, kind of lightly across the whole gamut of APRS. We'll do a little history lesson up into the technical stuff. We'll show some demonstrations. I'm not a presentation guy. When I go to these things, I like to play with stuff. So ultimately, I'm going to try to skip through this, and we've got a bunch of toys up front, and we want to talk a little bit about those as well. So let's talk about where the origins go. Bob Bruninga, WB4APR, essentially developed APRS over the course of many years. And he's kind of started dabbling with it in 1976. The birth of APRS kind of as an amateur tool, really the birth date, what a lot of people would think was when he published his article at the ARRL conference about APRS, and that kind of kicked the whole thing in motion. So he designed the very first digital RTTY system, which is basically packet stuff on radios, in 1976. He took that data, those position data over packet, and started applying them to his own software developed maps. And when he started doing that, he was able to start doing it in 1982. He wrote his first mapping software, and really at that point, it wasn't in the amateur radio community yet. He built it to track naval ships that were out at sea. So they were broadcasting their positions on HF over sea, and he was plotting them and getting pretty good accolades for that. 1984 is often attributed to when APRS was invented, but that really was when he first gave it a practical demonstration that he could pull it off and what he thought it could do. He used it to track a horse race, one of those endurance horse races. And he put the little trackers on the horses, and he put the little trackers on the people around him, and sure enough, on his little VIC-20 computer, he was plotting them on this little dot map, and he says, "See, it works." So that's kind of where that kind of came up. At the time, it wasn't called APRS, it was called CETS, Connectionless Emergency Traffic System. It was also, when he did that horse race, he realized his call sign could be used. And so, being the clever guy he is, he was able to find out APRS and APR in his call sign. A lot of people think he changed his call sign as a result of APRS. It was the other way around. He was always APR. And he changed it to the automatic packet reporting system. It was in the 11th ARRL Computer Networking Conference that he actually published his draft of this work of what APRS for amateur radio could mean, and that was when it really took off. The manufacturers got excited, everybody started getting really excited about what the possibilities are, and it just really took off in 1992. He's also the guy that designed the Mikey PIC processor that ended up in the Kenwood THD7, the little handheld radio that was really popular from Kenwood. They had the APRS and stuff in it, so that was kind of in there. APRS as we know it today, which is what the call sign substitution, we will get into all of this a little bit later, so don't get too excited, came about in 1996 when Patcom did it and Cantronics did it in 2000. That's when the entire APRS network was converted to the new wide-end paradigm, which is what we use today. Whew. All right, so there's your history lesson, if you would please, sir. So, all APRS does is take something, and we'll get into the somethings, converts it into a digital packet, and sends it out over the air. That's it. Now that digital packet contains a bunch of information in it. It basically consists of where the packet is coming from. And so in that example, you'll see KD6DL9. I just copy and pasted this from somewhere. It's going to have the equipment and software that is actually being utilized to transmit that packet. Most of the major manufacturers have their own designator. On this one, you'll see APTT4. That's the tiny track 4. Looks like this little guy. That's the piece of equipment that generated the packet. And then from there, you have a path. And we're going to talk about paths a little bit later, but that tells you where the packet went. So where it started from, the path that it took, and ultimately where it ended. And so from the KA60AC1 through the KF6SJ10 is really the path that packet took. So from the time it left his radio, it moved from one location, one digital repeater. Ultimately, the QAR represents that it ended up into the internet, and it was the KF6SJ10 internet gate that actually put that onto the internet. Okay? Where that little arrow is right there, I kind of highlight that because that shows you what kind of packet this is. And on the next couple slides, we're going to really talk about the types of packets that can be transmitted. In this case, I know by looking at that little @ sign that this was a position report. So he's got, a GPS hooked into his radio. It's given the position reports, and right there next to it, you can see the 19, 14, 16 hours. That's when it was actually transmitted. And then you have the latitude and longitude, which is 33 degrees 09.24 north, 117 degrees 10.60 west. Okay, so that's how you know it's a position report. And then off to the end, you have what's called the additional payload data. Now, a lot of that stuff on the end is optional, but one kind of interesting key thing is right here where it says 8 equals 00728. That's his altitude. So this one little piece of packet of data that his radio assembled based upon a bunch of input, whatever that input is. In this case, it was probably a GPS, but not always. It can be any number of things. In this case, a little GPS receiver is hooked to his radio. His radio goes, okay, I'm going to send this packet out over the air. It assembles all of this information into a packet, which is called an AX25 packet. It keys up the radio and it goes squawk, and it squawks it out. Okay, makes sense so far? All right. Now, so far, this, now that it's been explained, actually looks pretty self-explanatory when you kind of start looking at them and you start recognizing them. But Bob, being the guy he is, says it took 1.2 seconds to transmit that packet. If I can compress that packet, I can send it out in a fraction of a second, make the transmission shorter, allow more traffic, etc., etc. And he came up with Mikey. That's a Mikey packet. I have no idea what it says, just so you know. There's big translators. You can go online and input all this hex value, these binary values in there. Each one of those little symbols actually does represent something, but that is also a position report packet. So if you can imagine a radio keying up your, a piece of equipment keying up your radio and saying, I need to transmit something, instead of being long-winded like I am, right, the mic key goes, that's it. Chirp, it's a little chirp. So he did this intentionally because the APRS network was exploding in the mid-90s. It was becoming extremely congested. Everybody was buying little trackers, and everybody was buying the THD7, and everybody was buying the D700 Kenwood radios. They had all this software and all this equipment, and the GPS built in, and everybody was running it, and the network was absolutely getting hammered. And so he came up with a bunch of ways. One of them was the MIC-E, but the other one was the new wide-end paradigm, which we'll talk about as well. But it's important to understand that really at the end of the day, no different than when I key up a radio and say, my name is Eric, I'm calling from Ramona on mobile, and N6GOF, whatever mobile, your radio's doing the same thing. Okay, it's just assembling some data, squawking it out there. Any questions on what the packet is? Okay, we can move on. So, we talked about packets. The most popular packet that everybody loves to see is the position packet. And thank you to the gentleman for reminding me that there is a bulletin packet. They didn't put on here, but you can clearly see there is a lot of information that you can actually assemble and send out over the APRS network. Okay? Most people are familiar with the position report packet. If you do me a favor and press Alt-Tab for me. And again, hold down Alt. I'm sorry, go back to the presentation, press Escape. And you'll see APRS PHY's the third tab over. That one, yep. And you can just zoom out, zoom in, whatever. What you're seeing here is a real-time representation of the packets. Just, you can hit the little minus button right here, yeah. Just zoom it out a ways. There you go. Lots and lots of packets, okay? We're gonna get into weather stations here in a moment. But you're gonna see these are all real-time packets that are coming through the APRS network. And every single one of these stations, with the exception of the blue ones that say WX in the middle, we're gonna get to those in a minute, all of those guys are basically have equipment hooked up to their computer, and this is all position reports with the exception of the weather stations. All of these people, look, somebody's driving a balloon down the street. Their radio's connected to a GPS, or if they're a stationary station, they manually key in the coordinates. There's no sense in buying a GPS if you're not moving. And every so often, it squawks out the information, okay? All right, so this is all, is that our balloon driver? That's awesome. Now you can see the balloon driver and I are all sitting in the same location. While we've been sitting here this whole entire time, my truck has been sitting out in the parking lot, and every 10 minutes it reads the GPS, assembles a packet, and squawks it out onto the network. Now the question though is that's all fine and dandy, but how does this website, written by some guy in Finland, get this data and put it on this nice pretty website for me? We'll get to that here in just a moment.
Jeez.
All right, I know. Look how accurate that truck. My truck is literally in the front on the left side of the road. It's pretty cool, huh? That's pretty darn close. That's pretty darn close. It even has my truck pointing the right direction. That's pretty cool. All right. That's funny. All right, so we can hit the PARC APRS tab up at the top, go back to the presentation, we'll keep on boogieing down the road. And just hit present for me, perfect. All right, so now you just saw an example of what a position packet really, its purpose is. Its purpose is to give you the latitude and longitude of a device, an object, a car, a motorcycle, a balloon, the International Space Station, which I'll talk to here about also here in just a couple minutes. Now, they use those GPSs to get that coordinates, because obviously it doesn't make sense. You're driving down the road, you're not going to stop every 10 minutes, look at your phone, get your coordinates, plug it into your radio, and hit the broadcast button. So the radios are smart enough, you can plug a GPS in. Oh, I can't tell you how much I love the fact that this D700 that I started with, and I had to go buy a GPS that they no longer make anymore, so I ended up buying one of those stupid little handheld hiking GPSs, hacking it to get the data out of it, to plug it into the back of my Kenwood. I don't have to do that no more. All the new radios, all the new ones, they come with a built-in GPS. Oh, it's amazing. All right, the other type of packet that gets sent out is message packets. These are simple messages. Just like text messaging we do today, you can text message right on APRS.
And it might or might not make it.
And it might or might not make it. Now, you'll notice that the second line, the first line under that message says it is in fact the only ACK package, packet that is available on APRS. Everything else in APRS is fire and forget. The APRS network's pretty stupid. Your radio's kind of stupid. Every now and then it goes, you're telling me to broadcast my position, it broadcasts it out, your radio has no idea if it actually made it anywhere. Okay? So it just goes, every 10 minutes, I'm gonna scream. And it just screams. Hopefully something hears it. And we're gonna talk a little bit about how the network hears your information. Messaging is a little different though. If I were to send a text message to somebody, that remote station, in that payload, I can actually ask you, please, can you do me a favor and confirm you got this? And if that other station reads that and it says, all right, fine, you want a confirmation? It then turns around and sends a message back to me basically saying, yeah, I got it. Okay? Even that's not a guarantee because we have packet collisions and a whole bunch of other things, but it does add a level of some sort of assurance that we're actually getting our communication across. If you want to press escape again, hit the Telegram tab up at the top, the one that blink in there. And here you can see a messaging app that I wrote that works on the application Telegram, because have you ever tried to do, remember text messaging back in the old day where you had to go A, and then B, and then Z, and L, and Y. Up until the 400, that was kind of what it was like on most APRS systems, right? And in fact, most of them couldn't do messaging at all. I love messaging.
Or dial.
Or the dial, push a button, dial, push a button, dial, push a button. So a lot of people started getting creative, myself included, where I actually just wrote my own software that allows me to send messages through the APRS network using whatever computer I happen to be at. I actually tested it a little bit while early. You can see at the very top it says fail K6JPE9 test.
Sorry.
It's not your fault. Carlsbad is kind of a vacuum when it comes to APRS coverage. And so there was nothing that was going to, now I'll be honest with you, somewhere down the freeway, there was an iGate out there screaming for Joe. Just screaming. Joe's too far away though, so.
My radio is currently sitting up there and probably didn't have an antenna on it when that packet.
Right, so, but I do get an acknowledgement. Now, how do I know it failed? Well, I don't 100% know it failed. I know that I tried 5 times to send the message and never got an acknowledgement. So I'm just gonna chalk that up as a fail. That's kind of how that works. All right, we can go back to the presentation. All right, so text messaging. We can text message on APRS as well. That's kind of cool. We can place an object on an APRS map. An object, like a repeater site. Let me give you an example of a repeater site. One more time there, Mr. Computer Guy. Press escape. Go ahead.
It's not ours.
It's not ours, because I'm the one that puts all the repeaters on the APRS maps around here. So, no, Google Maps again, go right back to Phi again, and just zoom out, or you can just type Ramona in there somewhere, you'll see. Yeah, keep going, go. Okay, kind of move over towards Ramona a little bit. There you go, see that 145.30 right here? Right here? There you go. That's the Mount Wilson repeater. And you'll see if you click on it, it'll say who actually posted that object. So you'll see N6GOF10 posted that object on the map. I designated it as a repeater. I've set the frequencies, the offset, the PL. Those that are driving through the area can automatically receive on their screen your nearest repeater is, and they'll get the Roar's repeater right there in Ramona. Okay? So those are objects. Objects are kind of cool too because they're not people, they're not anything, they're just an object. I can put an expiration date on an object. So if I'm not constantly transmitting that object, I've told this one to expire after 30 days. Sometime within the next 30 days, N6GOF10, which is my iGate, must submit that object back into the network or the network will go ahead and remove that object from the map. So that comes in kind of handy too. Search and rescue, they use it to say, here's where the fire's at, right? Here's where the EOC is. Here's where the nearest water station is. If you're working a special event like the Baker to Vegas run, you put all the water stations on there. You can tell who's hanging out at the water station way too long, right? So people place the objects on the map. The Tour de Palm Springs, which I was involved in for a long time, was a lot of fun. We used to put all the water stations and the first aid stations and the bus stops and the transits and all that other kind of stuff. And it was always great because the coordinator would come up to me and go, how long has Joe been sitting there? And I go, 25 minutes. Not good, right? So objects, we can place objects directly on the map. One more time back to our presentation if you could. Status. Status is kind of one of those things, it's like your signature on your Facebook thing. It really doesn't mean, it's just a way for me to add additional information about my station. So I'm N6GOF1 when I'm driving my truck. Well, that doesn't tell you a whole lot. Well, the 400 is really nice, is that we can tell the 400, for example, hey, by the way, that status, I want you to put the frequency that I happen to be monitoring in my status. So as Joe's driving down the road, I know exactly that he's listening to the PARC repeater, or he's listening to the Wilson repeater. When his packet comes through, I go, oh, he's over on Wilson. I jump over to Wilson. Woodson, that's what I meant. Sorry, Woodson. On Woodson. So we could put all kinds of miscellaneous information in the status text. A lot of people thought it was kind of cool for a long time to put their email address. This stuff is on the internet, folks. You get a lot of spam if you put your email address. But, you know, you can put your contact information. You can put whatever you want. You can put your friend's email, right. So the status is essentially additional information you want to send with your position. It is a separate packet, but when the network receives a status text, it appends it to your station, okay? All right, the next one is telemetry. Telemetry, I did spell that right. I was worried about that. I was driving here, I'm like, did I put an E in there? Anyway, telemetry is really valuable in high altitude balloon projects. Those that use the telemetry stuff, I'm going to show you some examples of telemetry data in a moment. You can put anything from a digital sensor into your tracker and get that reported back through the network, over the air. Temperature, barometric pressure, battery voltage, any type of sensors that you want to put into your APRS packet, you can put those in there. And when you see a telemetry packet, it essentially gives you the number of channels that are available on the tracker, colon, and then a numeric value. Now I can write any kind of thing I want, right? So that's a telemetry packet. You can sometimes query a station. iGates and digipeters are fun to query. All you do is put a question mark in the call sign. It assembles a packet, sends it out. The digipeter goes, "You talking to me?" And it comes back with a nice family response. Here's all the stuff you can do with me, right? So it'll bounce back an entire reply back saying, here's the things, and here's my contact information, and here's where I'm at, and here's how long I've been here, and et cetera, et cetera. So you can query. Remember all those blue WXs that were on the map? We're going to get into QOP. I didn't say crap, I said QOP. QOP here in a minute, the Citizens Weather Observation Program, is the one who's responsible for putting all those WX dots on the map. They're the ones deriving all of this weather data. The weather data with the Pete Brothers Weather Station and a couple others, you put it up on your house, and anytime you want, you can get the temperature and the barometric pressure and the rain and the wind speed and everything else, and it goes out into the APRS network as a weather report. All of those also comes from the QOP network. So that's kind of interesting. And of course, as we have demonstrated its success, bulletins. I love bulletins. I'm the only guy I know of that loves bulletins. I put bulletins out on almost everything. Bulletins are essentially messages to nobody and everybody at the same time. You can take you send it to BLN 1, 2, 3, 4, or 5, and it's essentially a status text. But here's what's nice about it. Individuals like to get bulletins. They read the bulletins, and it comes up on their display nice and pretty and says, here's what's happening. So now, I can move those through digipeters. I can keep them local or whatever the case may be. But we also send out bulletins as well. Great way to get the word out for whatever reason, for anything else you can imagine. Sir, yes, sir.
Clarification on the weather.
I'm sorry?
The weathers are iGates. They're going directly to the internet, not over the air.
They only operate on the IS network. Yes, yeah. They're not actually, some of them are iGates, but most of them are strictly internet only. Yeah.
Because
and
they
so-
have licenses.
Correct, correct. So they actually receive identifiers and they don't RF those. You'll see some that do. A lot of ham guys or radio operators will run weather stations, and you'll see those as well. But you can actually go in and filter out the CWOP stations, and we'll pull that out. So we're going to talk about some of the other people that play with our network here in just a minute. Oh, great joke! Come on.
Hey,
No. What did you did? I was on a roll and I have to start all over. Just kidding. All right, here we go. All right, so everybody knows APRS is the great little cool tool where I can see my buddy driving down the street. But those that really dig into APRS, search and rescue operations, and a lot of telemetry stuff, you'll see that there's a ton of information that can be moved through the network. Any questions on the packet types? And this isn't all of them either. This is about half the type of packets, but they're the most common type, okay? All right, let's move on. All right, yeah, where our allowance goes. The toys, the gadgets, the gizmos. So before I get really into this, and we're going to talk about what type of equipment is needed to do this, it's important to understand that APRS network allows everybody to participate on a level that they feel comfortable with, or that they want to invest in, or that they want to be a part of. For example, if all I want to do is get my position on the air, that's it. No messaging. I don't want to receive messages. I don't want to receive somebody else's positions. You can go out and buy a Bionics Tiny Track 3, which is this little tiny guy. I think what's the latest retail price on these is like $50 or something like that. You get a little cable, you plug it into any old off-the-shelf handheld radio you can get your hands on, throw it in a briefcase, throw it under your seat, and you're on APRS. Okay? Very, very simple. If you want the full bells and whistles, I want to do it all. I want to see bulletins, I want to see objects, I want to be able to send messages and everything else. You take it all the way up this line over to the 400, the TMD 400 from Yaesu, which has FTM, thank you, boss, thank you. The TM 400, which actually has everything in it, including System Fusion, which is nice. But a lot of people who have to get the Fusion radio don't realize there's about 3 menu settings, and you've turned your rig into a full-blown, bi-directional, message-capable, bells and whistles APRS rig. It's kind of cool. So, with that said, you have essentially these major components. You've got the RF piece, right? We're radio operators. We've got to play on the RF zone somewhere. So we're going to put everything on a radio. You need something that can convert the digital packet into noise, because that's what the radio is going to put out. That's the AX25 packet. So essentially you need what's called a TNC. Most radios today have them built in. You don't even think about the fact that there's a TNC. The D700 and the 710, which actually has it now, did have this, see the little pink port on the front? That was how you could connect your computer to the TNC if you wanted to run the mapping software on your computer, right? You can do that on the 400 as well, actually, but yeah. But there is a TNC in there. There's that conversion piece that's built into the radio. Or you can get a standalone TNC, similar to this one. Anyway, so you need that piece that converts the to the, right? You need some sort of software, whether it's the built-in software in your radio. You can download mapping software on your computer. You can run it on your computer. I use Zaster, which is a Linux-based mapping software. What's the most popular Windows one? I forget.
APRS IS 32.
Yes. Yeah, or you can do it online, like what we've been demonstrating today, APRS.fi. It's the same tool. Does all the mapping for you. You just go to APRS.fi, it's monitoring every packet that's coming through the entire world and puts it on a nice little map for you. So you have online options, you have local options, you have embedded options, but you need some sort of software. If you're a moving station, you're going to need a GPS. As I mentioned earlier, it clearly doesn't make sense to be a moving station without a GPS. And then we have this monstrous backbone of a network that connects all of these listening stations, which are digital iGates and digipeaters and everything else, into one massive combined worldwide network. Keyboard guy, if you press escape for me, this time you will press Alt-Tab for me. This is what it looks like in real time on the live APRS IS network.
I want to make a note here. He just put me in front of a
It's the
root
matrix.
console.
So what you're seeing here now, in all honesty, all you're seeing here are messages or position packets that are within 30 miles of my house up in Ramona. Okay, that's all. But you can see here, this is what it looks like in real time as it moves through, and you'll see a lot of EL stations and an LS station and a whole bunch of stuff, a lot of messages, weather reports and storm watch warnings and stuff like that coming through the messaging network. But at the end of the day, there are a lot of people. There you go, it's telling my truck that the telegram gate's online. My truck has not answered yet in the last 30 minutes, so it keeps on trying. It's been up for 65.5 minutes. So what you're seeing is all this information. Now, there are volunteers and graciously a ton of money that runs in these big giant network operation centers worldwide that are keeping all of these aggregated and collected servers linked and connected together. These are what's called our core IS servers. I won't get all super geeky on you, but at the end of the day, imagine in a room, there's a bunch of servers and there's a guy who was gracious enough to put a ton of money and time and resources to make sure that America can talk to England. And there's a guy in England doing the same thing. All right, Alt tab. I wish this thing was touchscreen, that'd be kind of cool. All right, so, any questions so far? Because now we're gonna get really wicked. Everybody ready? All right, let's move on. Here we go. The path. The path was the biggest pain in the derriere in the 90s. The path was exclusively responsible for almost collapsing the APRS network. The path was a nightmare. And so I think it's very, very important that we talk about how path is, what path is, and why it's important to understand how to manage your path. Okay? Some history stuff here. Okay, it's revised in 92. This is the new wide-end call sign replacement method. You gotta understand that when this first started, Bob was not using APRS gear, it didn't exist. He was using the old packet BBS TNCs. Anybody who done packet back in the day? Lots of packet, right? These things started to fall out of favor. He's like, hey, these things talk AX25. My new thing talks AX25. I can make these work. Packet back then wasn't designed to do what APRS is today. And so they were kind of dumb in the respects of APRS. Back in the day, you did packet, you said, I want to use this digipeater to talk to that digipeater because that's where the information's at. And then that digipeater would tell this digipeater and send it back to you. So you had to put these very strict paths in there. Well, it got to the point where everybody just said, I want my packets digipeated 15 times. So 15 digipeters start talking. And you have a couple 100,000 people in the greater United States, everybody's saying, I want 50 digipeters to repeat my packet 50 times every 15 minutes, 5 minutes. You get the good guys who do it in every 60 seconds. Come on, it wasn't gonna work. So Bob had this great idea to revise this whole idea of a path. A path should only tell the next station what your intentions are, not where to go, okay? So he said, that's stop part one. The hops, the number of digipeaters that your packet should go, should be as short as possible. Ideally, as soon as you get within earshot of an eye gate, your packet should die. Nobody in Yuma gives a crap that the guy in San Diego was going up the 15. Okay? If he wants to know about the guy in San Diego, he'll go online and look at the locations. So let's stop moving it so far. We want the digipeaters to be a little bit smart. Hey, can you do me a favor? If this is the end of the run, can you just drop it? Or better yet, how about you adjust it and so that the next repeater can make that decision? Regional paths were encouraged. You'll hear in APRS, you'll hear a lot about the wide N paradigm. And that's kind of what I listed in the very top right-hand corner, wide N being a number dash a number. But if you're staying within a specific region, then use a regional path as well. You can certainly do that. Most digipeaters in Southern California will also respond to SCA. Because if you get some repeater up on, what's the One way out there by Big Bear. Huh? Yeah, Keller, places like that. Yeah, let me tell you something. It doesn't matter if your packet's not going to go any beyond that one because a guy 145 miles heard you. Don't worry about it, right? Now, if you put Y2, for example, and their Keller's going to go, I need this digipeated, and some guy in Yuma's going to go, okay, I'll digipeat it again, and he'll kill it. But anyway, you get the point. So keep it within a specific region. Special events will even use special event designators simply to say only digipeaters participating should do that. Okay. So the question is if you had an accident, could you use APRS? They don't really participate on that side of it all that much. No. You could, well, yes, you can. Yeah. No. They did, actually, at one point, which is kind of interesting. Riverside, Kern, and San Diego did, but they don't anymore. No, they do not. They do not. It's really, yeah, that probably wouldn't be all that practical. The next idea was to minimize collisions, and collisions is the same thing as two guys keying up on a repeater at the same time. If two stations transmit at the same time, it's a collision, both people lose. Or the guy with the bigger guns, I guess, could win. Because you've got to keep in mind that APRS is simplex. 146.39. 146.39. 145.39. It's actually on the next slide. I'm sitting here trying to guess. Anyway, all I know is my radio says APRS because I program it in there. Anyway.
Look at the frequency on the bottom.
Okay. 144.39. I don't know, it's 39. Sorry. Anyway, it's a simplex thing. So when two stations decide to broadcast at the same time, they collide, the packet gets dropped, it doesn't go anywhere, okay? So we want to try to minimize the collisions. Digipeater programs are actually programmed to look for certain paths. So for example, if you're a low-level repeater, you're a wide one repeater, or what's called a fill-in repeater. I'll show you what that means here in a minute. If you're wide two, you've got big ears. And you're way out here in the stratosphere, and you can hear a lot. As far as APRS is concerned, we can't have too many wide ones, but we got to be very careful about the wide twos. In very, very limited situations, we have a digipeater that's both a one and a two. But generally speaking, you've got the little guys down on the ground floor that's listening for these little milliwatt transmitters. Anybody? I was going to bring a picture of one, or I was going to put it in here, and I completely forgot. Some guy in Germany just recently came out with a transmitter that is no bigger than my pinky. I mean, this thing is itty bitty. 0.2 milliwatts. And he goes, doesn't matter how small the transmit range is, in Germany we have lots of wide ones. Every other house has a wide one in it. We love the wide ones, so he puts them on. So he's got this cool little thing. The whole idea of a wide one is to hear the little stations, they got more power to hit the wide twos. Somewhere between the station, the wide one, the wide two, and that final repeat from wide two, hopefully an iGate picks them up. Maybe. We'll show you how that works. Now, the digipeater sees an alias that it should act on. So for example, if you're a 2 or a 1 or an SCA, as most in California are, it should check to see if it should continue. For example, if you were a Y2, looking at after the Y2-1, that means from the time I transmit it, I want it repeated one time by a digipeater that is designated as a Y2. Make sense? In almost most of Southern California, you can get by with a Y2-1 and you're done. But generally speaking, what most people are recommending is Y11, Y21. And I'll show you an example of that here in a minute. When the digipeater gets that, he's going to deduct a 1 from that digit after the dash and reduce it by 1. If it was a 1 when he got it, he strips it, the packet goes no further because the next digipeater will hear it, but the next digipeater doesn't see that there's a dash number, and so it goes, well, I'm not going to digipeat it. Does that make sense? All right, so let's see what that looks like in practicality. All right, so in your radio, when you do your APRS, one of the things you will set up is the path. Every time your radio transmits, what path will the packet take? In Most of California, you kind of look at it, and that's probably typical, wide 1, 1, wide 2, 1. If a digipeater is programmed to look for both wide 1 and 2, it starts from the left. So it sees a wide 1, 1, so it will retransmit it, but now look what the path turns into when he echoes it back out. Though dash 1 is dropped. Okay? Right. So now it's just wide 1, comma, wide 2 dash 1. Now the next digipeater is going to get here, the first digipeater, and go, all right, I need to analyze the packet. Well, there's nothing to do with wide 1. That's already been concluded. So if I'm a wide 2, then I'll digipeat it. If I'm not a wide 2, then I don't do anything with it because it's not talking to me. Does that make sense so far? All right. Let's say it's a wide 2. A digipeater is programmed to both for look 1 and 2. So it'll retransmit it. It now converts the path to wide 2-1. It transmits it. The next digipeater gets a look at it and says, is it for me or not? Am I a wide 2? If I am a wide 2, I'll do it. I'll retransmit it one more time, and we're kind of right back to the first scenario. Up in Ramona, sitting on my little house, I've got a nice little wide 1 fill-in digi. If I'm cruising down the road and somebody's got wide 2, 1 as they pass my house, my digipeater's only told to look for wide 1. It'll hear it, but it won't repeat it.
Will it I-gate it?
I am also an I-gate, so yes, I will I-gate it. Now, I-gates are kind of dumb. They don't really participate. Either you are a digital repeater, or you are an I-gate, or you're an I-gate digipeater. Make sense? So, but it's actually 2 distinct roles, completely 2 distinct roles.
So if an I-gate hears it, no matter what it is, it's going to gate it.
Correct.
So a wide 1, 1, wide 2, 1 passes by, your repeater will digipede it, send it out to a wide 2, and I-gate it.
And I-gate it at the same time.
Wide 2 will probably also I-gate it.
Now, a lot of I-gates aren't digipeaters at all. They just listen to what's passing overhead. So you'll look on the map, you'll see a lot of black diamonds with an R on it. Those are receive-only gates. They don't participate in the repeater process at all, but they hear all the packets moving overhead, and as soon as they hear them, they throw it out to the IS network. Next slide. So it looks like this. Okay? So here's me, I'm bebopping along. I have a wide 1, 1, wide 2, 1. So after the first digipeater, the path now looks like that. It rewrites the packet, and it looks like that. Notice the star. The star says, done. End of the road. In some cases, some digital repeater owners will also apply a trace value into it. In the event of a trace, I didn't lay that out here, but let's take this wide 1, for example, and let's say that this first digital repeater right here, the call sign on it is N6GOF10. If I am the last player in that chain, I'll actually replace I'll replace wide 1 with N6GOF10. Okay? All right, so this is how that packet kind of moves along. Go to the next slide, and you'll see how I-gates work. Okay? I-gates are the gatekeepers between the IS network, which is the internet network, and the RF network. I-gates can, or they may or may not participate in the repeater process, but they do participate in anything that's passing overhead. Okay? So in this case, there's an I-gate here that happened to hear it as it was being repeated from this digipeater to that digipeater. It went ahead and dropped it. The I-gate will actually change the packet itself, put the last digital repeater in here, star it, which means terminate it, the I-gate's call sign, and then it'll put a QAR in there. The QAR is an IS code, which basically represents how that packet was heard. But that's what the path will ultimately look like when a gate gets to it. Everybody with me so far? Told you we were going to get a little geeky here. Hang on. All right. So the I-gate plays this critical role. It's the translator between IS, the Internet Services Network, or the RF network. Okay? All right. Can you start, Joe, please? All right. We talked a little bit about collisions. I don't think we need to do that. What's the best answer for a collision? Be smart with your paths and repetition. Repetition. Bigger transmitter. There you go. Need more power. Right? Put a linear in my truck because I want to make sure I get hurt before Joe gets hurt. Okay. All right. So we talked a little bit earlier about who also plays with our APRS network. We have the Citizens Weather Observer Program, CWOP. If you buy a Pete Brothers weather station, there's information about how to join CWOP. And you go to CWOP's website, you ask, can I participate? They're going to give you a distinct designator and allow you access into the internet portion of the network, of our network. That's how all those little blue WXs show up, because that map is looking at everything coming through the internet side, and it just puts them up there. If you're driving through town right here, you won't hear all those weather stations over the air. Ships at sea, they have their own HF frequency that are coming out from ships at sea. They're gating them out to the internet network. Joe, if you wouldn't mind, go back, back up. Go back to APRS.fi. And the very top right-hand corner, see that little block with the arrow on it? Yeah, that one. And put track call sign N1ZZZ. This guy's got the coolest job in the world. Oh wait, where is it? Oh, that's from the WinLink one. Oh, gosh darn it, where was it? I thought it was N1ZZZ. No, shoot. No, it's a yacht. This guy's so cool. This guy's a captain of a private yacht, and he was in the Persian Gulf yesterday, and he's a big kind of a hot guy. I thought it was for sure it was N1ZZZ. I may be mistaken, I'm sorry. Anyway, he uses the ships at sea service. Yeah, it's Florida, but you see, look at all those boats. See the concentration of red right there? Go just zoom in all the way into one of those harbors. All of those boats. That's a dredging ship. Look at all those boats. All right, these guys are not on our amateur radio network. They're not the ones beaconing out on the RF side. They don't have trackers in their boats. Okay, they're on a separate, completely separate system that actually tracks all of these vessels worldwide via HF. And so there's listening stations all along the major coasts around the world that are listening for these reports coming on the HF side, and they're listening and they're dumping it right into the internet network as well. Okay, so you'll see merchant ships, basically almost, I forget what the rules are, but I think it's darn near every single ship around you. That driver is done. Put that guy to bed. And he almost made a star out of it. That's pretty cool. So the boat guys. All right, so let's go back to our presentation.
Here's your red or ships at sea.
The red is the density of the, yeah. A lot of software developers. There's a lot of people who have the iOS or Android version of APRS on their phones, okay? Or if you're the software developer like I am, I wrote the messaging app on Telegram. So we have a lot of people that are writing software that are really on the IS side only. They're not participating in the RF side. Now the APRS developers who are writing the APRS software, the trackers and Droid APRS and all these others, they're nice enough to confirm that they're operators before they put stuff in, but they don't have to technically because there's no RF piece, right? So, but you'll see a lot of software that pops up that reuses and reads a lot of this APRS data. Now, iGates, remember iGates can talk to both. So they're talking to the RF and they're talking to the internet piece as well. You can program an iGate to do just about anything you want. So I can program my A-gate. In fact, that's what I do. If a station comes through Ramona and they have never, and they're not using RF, okay, so they're not using a radio. So for example, they're using Android APRS on their Android phone, or they're using the APRS software on the iOS. So they're putting it on the map, but nobody around them in the RF side knows about it. I'll gate them for them. Okay, so if you're a radio operator and you've got one of those APRS apps on your phone and you're passing through Ramona, my A-gate's gonna go, poor guy, I haven't heard you over my ears, but I can see with my eyes, so let me go ahead and send you this out for you. So I gate that for you, because we do have a number of APRS operators that are RF only, right? So we run the TD700, we got the software in our room. This guy's passing right through Ramona, but we would never hear them because some guys are listening RF only. So my gate will go and go ahead and RF you, so if you're passing through. Okay. APRS, Amateur Radio on the International Space Station. I love doing this. I make contact with those guys probably about every 3 days. It is kind of fun. So as the space station is passing over, you change a frequency. I tried remembering frequencies a minute ago. I'm not going to do that. Change frequencies. You'll hear the space station pass over. and you try to send a packet, and people will hear your packet, and there's an actual software on the IS side, RS0 ISS. When it hears you, it will actually send you a message through the Telegram network saying that you successfully transmitted up to and back from the space station. So it's kind of fun. So if you're looking for the messaging threads, all you have to do is, like in Telegram, you can join messaging groups. Put yourself in the RS0 ISS group. You'll see people getting their confirmations pretty much almost around the clock from all around the different world as they're talking through the space station. There is a TMD 700 on board the space station, the same radio that I have up here. It's been up there forever. I think since Kenwood first came it up, the next mission brought one up there, and it's been sitting up there ever since. So if you want to play with the space station, they're kind of fun to play with. The amateur. Yeah. They do some cool stuff. Now I heard rumors, somebody confirmed this for me, that NASA requires that at least one amateur radio operator be on every space mission. Is that true? Or they all are, or at least one has to be, or something?
I don't think so, 'cause I don't think there's currently one.
Okay. I don't know. I thought it was kind of interesting. Okay. Oh, it's kind of interesting. Yeah. Of course, APRS is, automated. It just kind of sits there and does its thing. But it is kind of fun and interesting. So if you want to play with that, you can play with that. Amateur radio, high altitude ballooning. Man, you go on any day or night. It doesn't matter. There are a lot of stations. Switzerland. I don't know, some of those Eastern Bloc countries and stuff like that. They use telemetry on almost every weather balloon they launch, and they use the APRS network. Now they may put it into their own frequency, but it's the same thing. So you can go online, watch high altitude balloons. It's always fun to see how high they go. And WinLink, which is an HF to APRS messaging for ships at sea. This was their answer to instant, text messaging. So it's kind of cool. If you're interested in participating in that, you can go to WinLink's website and actually become a part of that network, which helps a lot of the sailors and sea, merchant marines and stuff like that. They do that. Whoop. What to do with it? Mapping, telemetry, messaging, search and rescue, special events, and let's break it down. Whoop. That's what it looks like on a map. Go. That's what it looks like in telemetry. Go. That's what it looks like when you do messaging. Go. All right, I want to stop here for just a second. Search and rescue, which is really what I first got into APRS for. Special events are a great way to practice your search and rescue, but search and rescue in and of itself is really neat. This is a map of a search and rescue. You can see they've identified the flood, they've identified the gate that's being operated, and you have the stations and the operators that are working this particular disaster scene. It's great to put it up on a big projector. If you guys want to do the tour to Palm Springs, let me know. We can go do that. That's kind of fun. But search and rescue is fun and very important, I think, in my opinion, to really what APRS could do for you. I know somebody who's a big off-roader. He uses it to track his buddies as he goes off-roading through the desert. Another great way to track and keep track of people as you move around. All right, go. Special events. This was a buddy of mine following a runner on the Baker to Vegas run. That's a long run, but the guy sat behind him and rode him along all the time. Next. Okay. We're almost done, Joe. Hang on. He said, hurry up. All right. So APRS is a standard, not so much a technology in the sense. D-Star and Fusion systems, D-Star and Fusion, are now taking APRS data and dumping it directly into the IS network direct and bypassing the RF network completely. So if you see D-Star stations on the map, they didn't come in through the RF network. They have the GPS data, they're on a digital network already, they have access to the internet already. So Fusion and D-Star can actually drop it directly into the IS network itself. However, Fusion radios are capable of coexisting with the standard APRS networks. Disclaimer, because that's exactly how I do it. In your Fusion radio, you go into the settings, you dedicate one of your subbands as an APRS, and it automatically uses the traditional APRS network. Who knows what the future holds? All right. Big pictures of everything that's up here. All right, so we have some stuff. If you would like to go through them, we'll talk a little bit about the pros and cons of each kind. Stuff like, this guy. We already talked a little bit about the tiny track. It takes a GPS signal on the left, keys up your radio, and squawks it on the right. That's really essentially what a tiny track does. The newer tiny tracks can do a lot more. They can digipede and a few other things, but Built-in APRS receivers, the D700, which a lot of people have seen. It was really the first all built-in, all-in-one APRS radio. Ken would put that out. This is actually my iGate that's sitting up in Ramona. Not tonight, but normally sits up here. This is the PC3. This is, when I first got into it, you had to know Linux, because you had to run Linux software and then do all the porting and the keying and everything else. These make it really handy. Pick these up at HRO for almost nothing. Plug an Ethernet port in here, it's got a web server. You put in the specifications and you walk away, it's really nice. The 400, which we talked quite a bit about. The one thing that 400 doesn't do, actually none of this does, is put it on a nice pretty map as you're cruising down the street. I'm going to hand it over to Joe, because Joe has this cool little thing that he's done with a Windows PC. He actually takes all of the data, Windows, Android, sorry, an Android tablet. The 400 is capable of also dumping all of the packet data out, and so he can connect an Android tablet and actually watch the stations as he's going down the highway, plot directly on the map.
Yeah, so the FTM 400 and I believe the FT2DR also comes with the USB cable. Am I good audio now?
Yeah.
Okay, sorry. So yeah, the Yaesu was nice and actually gave us the USB cables, but if you set the options in the radio to output the packet data via your COM port and get a on-the-go cable for your tablet, either Android or I do actually have a Windows tablet here also, but the battery's dead. That's why I'm not using this one. So, and it's Windows. Yeah, that one hasn't been plugged in for 3 days. This one I have to plug in every 30 minutes. Yeah. And another neat thing that Eric has gotten working, I haven't gotten it working yet, but I'm planning on it, and I've already purchased it, is an Android 2-DIN head unit for my car stereo. He has one in his golf cart. But it can take the output from the FTM 400 and display your position right on the APRS IS app for Android right in your car stereo. So I'm excited to get that put in my Jeep. I was going to have it up here, but I couldn't figure out how to bench power it without completely disintegrating the wiring cable that came with it. So that's about all I had on that.
That's all I have. So, unless you have any questions?
Any questions or comments?
I do Q&A.
Well, we're just about out of time here, so I think the demonstration, well, I guess there is a demonstration here, but you can't really see it very well. I have on my screen here a whole bunch of N6 GOF, oh, hey, there's another one. And my radio just beeped because I have N6 GOF-1 set as a notify on call sign. So radio beeped, and there it goes again, there's N6 GOF-2. And it's also appearing here on my screen. Because this antenna is inside, I'm not hearing much else, but thank you, Don, for the use of the antenna. And I'm able to hear the vehicles outside and the radio that's sitting right there. And it's getting plotted right on this map here. So that's about the only demonstration I have. I could send you a message.
You give it a shot, there's no like, oh yeah, go to right.
Yeah.
Go to right.
Can I mention something, everyone, while you guys are starting this?
Sure.
Every year, the group called Chapter runs something called the Digital Communications Conference. And that is where, among other things, I met the father of APRS from Annapolis. And they're always floating new variants and new changes, stuff that can be done. And for those of you who don't deal with APRS at all, you might actually start using the base protocols underneath this if you ever get any of the newer home control networks for turning your lights on and off. The base technology came from APRS. Most of the mesh networking protocols that you're starting to see where everybody says it's a mesh network, all of that stuff was originally stolen for APRS. And when they had that collision years ago, where they filled everything up, everybody that was trying to do mesh networks watched to see how they were going to fix it. And that ended up being the basis for all of the little modern mesh networks like the ones that turn your lights on and off in your house, other than X10, all the newer ones. And a lot of the mesh networking stuff that's going on in the world now. It's all stolen from here.
Cool. So I've got a message set here for N6GOF-2, and I've just typed in hello. So I'm going to hit message TX here, and there it was. And I just got the acknowledgement.
Yes. So I turned my audio way up so you can hear it. That squeal was the packet. This radio actually also right on the heel that gave me you have a new message tone. So it's a squeal and then a bebop. And then immediately it turned around and sent a transmission back to this radio saying that's a message.
Oh, right. When we first put up the fusion repeaters, we had a PL issue. It was still digital, but it wasn't APRS digital, is what you were hearing.
Yeah, I was hearing.
Sounded the same.
Yeah, but we were hearing a lot of it, and then all of a sudden, that was weird, so I guess we fixed it.
Nope. Just people don't send as much digital now because the future repeaters aren't KOS.
Well, and I think we've schooled everybody that you need to have the PL tone squelch turned on, so that only the voice.
Well, I did have questions for you.
For Mark?
What I do this time.
You didn't do anything, but, computers
Yeah.
are not turned on the digital side, they're not turned on the FM side.
They are on the FM side. Yeah. We can talk about that after. Are there any other questions for, yes?
This path information is included with every, call it frame, but every
Packet.
Yeah, every packet goes out, has path information of some kind. Depending on how you've configured it. You could configure your radio to not send any path information, in which case any digipeater that gets it will say, I don't have anything to do with this, so I'm going to drop it. An iGate will gate it, but any digipeater will say, I don't have any instructions here, so I'm not going to do anything else. Anything else to add to
So
that?
for example, a lot of iGates will send out their status texts
With 0 path. They won't put a path on it, because basically they only want to talk to the people that can actually hear the station direct. So the one on Ramona says, N6GOF10 Ramona iGate. It squawks at about every 30 minutes with no path. So really you have to be within about 8 blocks of my house to hear it at all.
everything is considered payload, and then it's somehow delimited to sections that being to determine the path.
Well, no, you have the path, which actually says here's where I want the packet to go. And then beside the path, you actually have the data itself. So here's what you're sending. And then before that, if you look at the packet, it's a lot like a header, yes. Yeah, yes, in a way, yeah. Any other questions for me? Yes, sir.
Is everything a single packet, or some of these messages multiple?
Everything is a single packet. If you do an APRS message, the maximum message length is 216 characters, I think. If you write one longer than that, it'll take one packet, send it, second packet, send it. It breaks it up into multiple packets. So every packet is sent with a different separate piece. Yeah. Yes. If that's the radio you have on the bottom right, if it's the 700 and not the 710, you just need a GPS. If you're going to be mobile with it. If you're not going to be mobile, go into the settings and set it up manually, turn on the APRS software, and you're done. Yes, sir.
I have a question. I assume that if these are sending packets out every so often, I don't know when you set that.
You can set the parameters on how often they transmit.
And so it can track you along the way. Do you use the radio at the same time for other things? Or do you just have to do that thing?
So in the case of this, so this is actually a dual band radio, but if you participate in APRS, you're sacrificing your second band. So it uses just that second band. Correct. Correct. Yeah. Now, if you take a dedicated radio,
So for example, on the 400 here, I have this top one set to the Oceanside CERT repeater. I thought I could hit it from here, but I can't because we're inside and the antenna's inside. But that's on the top, the A band, and on the B band, I have that set for APRS North America. And I just have the volume turned all the way down on the B band, and I just can't use the B band for anything else. So that's that. And you were saying about the dedicated radio.
Yeah, and if you have a dedicated radio, then that's all it can do.
But what about on iOS? Do you recommend a good app for that? Unless there's several of them, I would find one.
Yeah, there's a couple of them. I toyed with them. And I'm sorry, I don't know the gentleman's name. At the end of your table there, second in from the end, he was showing me the app earlier today. And I think that's the one that I would use too. It was Open APRS is a good one. Yeah.
But the iOS apps, as far as I'm aware, are internet only, IS only. So I'm not aware of any of these that can
Pocket packet.
pocket packet,
It's $5.
and you can connect it to a radio then?
Yeah, it does both.
Interesting. What interface does it use to connect to the radio?
Headphone, it's just audio.
Oh, okay, gotcha.
Yep.
All right, so there is an audio one that connects to the radio via the headphone jack. That's kind of neat.
Does it automatically set levels?
Just now.
Oh, so you,
You gotta
Right.
fine tune it.
Oh, is that just on the web or is it an app? Oh, okay. All right, so APRS FI has their app. I use Open APRS. It's all the same data. It's all getting it from the same place. Okay, $5 or $6 for APRS FI. All right. Yeah. Okay. We are over our time, and thank you, Eric, for a fantastic presentation.